Are we ready?
Good luck.
Yes, and we are rolling on all four, so clap away.
Numbered dots. We might come up with a more creative name for this one. I can keep on connecting these and asking the kids to connect them, and maybe I end up with something like this. And then I say we want to have the numbers 1, 2, 3, and 4. So tell me where you would like to put the numbers 1, 2, and 3, and 4. So I would again go around the kids. I'm not looking for hands raised. I don't want the extroverted students only to know how they're doing. And I have not told the rules for the puzzle. I'm looking for a communal failure to engage the whole class. So the kids might come up with something like this: the 3 there, the 4 there, the 2 there. And then it's time to switch colors. I'm going to go for this. What number would you like to put here?
Number 5.
Number 5. And which number would you like to put here?
6.
6. 5 plus 6, is it equal to 4?
No.
Oh, no. No. So nobody knows the rules. So yeah, there's a little bit of humor, silly humor. Grade 2 style humor. So no, this doesn't work. Darn it. Okay, let's try again.
Can we put the number 1 here?
Oh, that's good. So this one's happy. That number's happy. We could put 0 here.
Mm-hmm.
That would maybe work. 3 plus 0 plus 1. Oh, it's still not good.
So maybe we can put a 2 instead?
Okay, so this was a disaster. I raised them
that was
all. Oh,
was
but
good.
the 1, yeah, we could keep the 1. Okay, so
Yeah, with the 0
but
and the 2.
whenever we're in the classroom, we have these epic fails. Okay, we don't have these little fails where, oh yeah, we could have kept the 1. No. We have an epic fail. So we've got, then they realize, okay, the 1's good. Okay, what number do you want to put over here?
Put a 2 instead?
2. And here?
Well, it'll have to be 0 now.
Good. 2 plus 1 is 3.
Mhm.
Yeah, okay, this is good. Now you want to be the slowest person in the classroom. And you might want to even celebrate whenever there's a mistake on here, saying, yeah, it worked. For like if they put a 1 here, you could say 2 plus 1, that's 4. But it's not. Darn it. So you can be the slowest person in the classroom. No need for you to be doing anything more. What are we going to do down here?
Well, now we must put a 2 here.
Yeah.
I guess.
Mm-hmm.
And this worked. Look, we did it. Because 2 plus 2 is 4. 0 plus 2 is 2. We've done it. So this is how to solve one of these numbered dots. You have to put the numbers 1, 2, 3, 4, and keep on going. Like if we put in, if we have 5 dots, we have to put the numbers 1, 2, 3, 4, and 5. And then you have to populate all of the edges with a different color afterwards so that you make those add. Is it always going to be possible? I don't think so. For example, if we did this, if we put the number 4 over here and the 1 here, if the kids decided to do that, it's not going to be possible because this would have to be 4 in order for this to be right. So not all arrangements are possible, and that's good. If we ended up with just a failure, okay, that's a failure. So this is the puzzle, and actually I didn't even know that this was possible to solve. I did solve. Where did I solve? No, I did solve it with 4 here, but I didn't solve it with 3 here. So I didn't even know this was a possible arrangement to solve. So I thought I was setting these guys up for failure, but I actually wasn't. Yeah. Okay. So thoughts? Here's a puzzle that you can imagine that these can become very, very difficult. Mm-hmm. It's also fun for kids to make their own, and it's also fun to solve these. Now, solving something like this is beyond grade 2, but you can actually get the help of algebra whenever you're in grade 8 to make some intelligent choices and then use a variable to solve the rest. And that often works, that approach often works. Do you want to try solving this together?
Does it take long? Yeah.
Yeah, I mean, you can try. If it
Okay.
takes too long, then we'll stop.
Okay.
Yeah.
Yeah, I can see how that could be tricky.
Yeah.
'Cause this one has all these edges coming into it.
It reminds me of Bridges somehow. You know the game Bridges?
Tell me about it.
Yeah, it's one sort of you have like numbers and you have to sort of connect numbers until there's some,
Yes, that's right.
yeah.
Yeah, it's a wonderful Japanese style
Yeah.
puzzle. Yeah.
Because here you have to decide sort of where the one goes, so you have to connect the one with one of these.
Yeah.
And
So
then
most of
there's
these are
also-
going to be zeros,
Yeah.
but one of them is going to be a 1. So the good thing about this is that there's multiple solutions.
Oh.
So maybe I'll just show you. And I used algebra to solve it, so I just made some
Yeah.
assumptions. And okay, so here I just made some assumptions. And I think I forced the 1 to go up. Then I knew all of these were
Exactly.
zeros. And I just made some intelligent choices and then solved the rest of it with algebra. Saying if this is x and this is 3, well then this would be 7 minus x minus 3. So
Mhm.
yeah. And this would be another solution of the same one, just with this time choosing the 1 to be here.
If you were to design one of these puzzles, how easy is it to make a puzzle which has solutions?
This I don't know.
Okay.
So it's certainly, this was very easy for me to design it.
Mm-hmm.
But I'm a designer, so
Yeah.
I wouldn't say that necessarily this is something that the kids would all find easy. Yeah. And also the aesthetics are not obvious. You see, what I've done is I've made the edges. I kind of made an aesthetic choice here, but that's not super easy for kids.
Mm-hmm.
So I'm not sure where to how far to push this. In kids get to design their own puzzle.
Yeah.
In many cases, this is the best. Is whenever you have kids play, they've solved some of them, and then they make their own puzzle. I think this is going to be good actually, but not all of their puzzles are going to have solutions. And instead of choosing something as complicated as this, they have to start out designing a puzzle with only 4 dots. I think this is the solution. And some of these aren't going to be possible, some will.
Mm-hmm.
And maybe before they hand that puzzle over to somebody else, they have to know that they can find a solution. Yeah.
They can play around with all these different shapes and ways to connect just a few dots. Not so many with 4, I guess, but
Yeah. And just there's going to be patterns that you can discover with this, and you're also going to be able to find that for 5 dots is this possible, and you're actually going to find no, that it's impossible to do with any 5 dots in any arrangement. That's kind of interesting.
Any numbers?
No numbers 1, 2, 3, 4, 5.
Okay. Oh, okay.
Yeah.
Mm-hmm.
So why is that? So for kids in algebra, why is 5 dots impossible? Well, 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. And each one of these edges is going to contribute to 2 different dots. So there's going to be an odd even problem getting to 15. But by the time you get to 7, and 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, that's going to be 28. So then, it's possible again. So there's some interesting parity stuff to explore for kids, more advanced kids in grade 2. Okay. let's.
No, wait, but what if you do like this has 5 dots and 1, 2, 3, 4, 5, 6, 7.
Go ahead.
Yeah.
Try solving it.
What I mean is because I don't see the odd even argument
Okay.
here. Because like if you do have 7.
Okay.
Yeah.
So try. And let's do it actually really big. So
Okay.
we'll say, Daniel, this was a disaster. Okay. We need big. Yes. Okay, and you don't have to do that. You can. Oh, and I guess
Then
they
you
can,
will
they
6.
can be 0 if you want.
Oh,
Yeah.
Yeah.
But that's cool.
Yeah.
Okay,
True. Yeah.
so there we go. So I'm going to put a 0 there if you're putting a 1 over there. There's my 0. So what, we could model this algebra, if that's...
With like put a variable here.
Yeah, we
Somewhere.
could.
Mm.
Like you're saying like this could be like some x. So this is either 0 or 1 or 2. But then this would have to be like 2 minus x.
Yeah,
Yeah.
Mhm.
and then maybe you want to just make a guess over here.
Yeah. So like 1.
Okay, well then I know this is 4, which is not going to work because already I'm above here. So
Yeah.
choose something else for 1. Okay, so that's 2. That means that this is 0. So we actually didn't need the
Yeah.
algebra.
No, it doesn't work here.
And then this is 2.
Yeah.
Okay,
It's not working here.
yeah.
Yeah.
So we're exactly 1 above.
Uh-huh.
So I think there's still a parity issue because each edge donates to 2.
Oh, I see. Oh, that's the problem. It's
Yeah.
That's the
Mm.
parity issue. Okay.
Yeah.